So now let's turn our attention to a different modeling technique in the use of polynomials. So polynomials. The kind of most common polynomials we're going to see are going to be quadratics. So we often want to use polynomials, usually quadratics or simply quadratics. When you want to represent a certain kind of relationship between the two variables. When you want to represent a relationship that is not likely to be linear. So we kind of learned about using logs for that percentage change. That's the one modeling technique we kind of learned about at the beginning. And now we've kind of expanded to multiple regression. We can think of different ways of having these nonlinearities. Remember, nonlinearities in our variables, not our parameters. We need linear and parameters. So it's important we must look at partial effects. At the partial effects. And we'll see how this is taken into account this nonlinearity. So let's say we have, and let's use a different color. It looks very blue on this board. So we have our dependent variable y, and let's just keep it really simple. We have two x's. We have x1, so beta 1 times x1, plus beta 2 times x1 squared. So this is a polynomial, right? Because this is a quadratic in x. We're allowing this non-linearity in this relationship between x1 and y. So, we can't just look at the partial effect. We can't just interpret this beta 1 as a marginal change in x1, the effect of that on y, because we can't change this variable without also changing this one, right? And so what the partial effect here is take the derivative of this with respect to x1. And so a marginal change in x1 now is causing a beta 1 plus 2 times beta 2 x1 change in y. And so the marginal effect of changing x1 now depends on the level of x1. So let's think about different different shapes that this relationship between x1 and y could have based on different signs of these beta 1 and beta 2. Okay, so we wrote out this really simple regression where we just had 3 parameters that we were estimating, but we had this quadratic in x1. So we had x1 times beta 1, then x1 squared times beta 2. So these aren't collinear. We don't have to worry about perfect multicollinearity because they're not linearly related, right? So we just decided that the change, because we took the derivative, the change in y from a change in x1 equals, just taking the derivative of this regression, is beta 1 plus 2 times beta 2 times x1. And so kind of this relationship between x1 and y is going to depend on these two signs, right? So one thing that could happen, let's say beta 1 is greater than 0, beta 2 is less than 0, and beta 1 is greater than beta 2, then we might have something that looks, a relationship that looks like this. So here's our y variable, here's our x1. We're going to have something that looks like this parabola here, right? So could have drawn that a little bit further, I guess. We have this, decreasing marginal returns if beta 1 is greater than 0 and beta 2 is less than 0. The other thing that we could see in different applications, depending on which applications we're looking at, I'll just put a line here, is that maybe beta 1 is less than 0 and beta 2 is greater than 0. And again, let's say beta 1 is greater than beta 2. And so what's happening here, if we wanted to draw this relationship out, think about what's happening here, is that at the beginning, the marginal, because beta 1 is greater than beta 2, this negative effect is bigger than this positive effect. So we have this decreasing returns to whatever this x1 variable is, but eventually it kicks back up as this second term starts to overpower this first term, right? And so, something else that might be interested in, if these are the, two different possible relationships between x1 and y, we might also be interested in kind of where they're maximized, where this, returns to x1 is maximized, or whether the returns to x1 are minimized. Well, we know how to do that. That's just taking a derivative and setting it equal to 0, right? If this is the partial effect, this is the slope of this line, right? This is the marginal effect, it's the slope of the total effect. So if we set that marginal effect to 0, so this is the marginal effect of x1, if we set it to 0, we can find either the maximum or the minimum, depending on the signs of the beta ones. We could also have more relationship. If they're both greater than 0, we have this kind of increasing returns. But these are the kind of the two most common ones you see. And you'll want to be able to think about how you calculate the max and the min based on these kind of marginal effects.